Hello class, good day everyone. I believe we are making the most use of this lockdown and we're taking our studies serious and also bonding with our various families. Alright, so in order not to waste too much of our time, I'll quickly go into what we want to look at today. What we have here is what? Trigonometric ratios. I believe you have seen it before. This is not your first time, but let's go over trigonometric ratios. But before I go into the gist of today's lesson, I would like to state the objectives of this class. That is the things you are expected to learn or the things you should learn at the end of this class. Number one is this. At the end of this lesson, you should be able to identify a right angle triangle. Excuse me. You should be able to identify a right angle triangle. And number two, you should be able to identify and name the three sides of a right angle triangle. And number three, you should be able to identify the three basic ratios of a right angle triangle using the SOHCAHTOA. So let's go into the gist for today's lesson. Now, whenever you are discussing trigonometric ratios, the first three basic ratios can only be used for a right angle triangle. That is why we are dealing with a right angle triangle. A right angle triangle is a type of a triangle. Now, what is a right angle triangle? Some students will say that a right angle triangle is a triangle that is facing right. But that's not true. A right angle triangle is a triangle that has one of its angle to be 90 degrees. As one of its angle is 90 degrees. We call that angle a right angle. And this is how a right angle triangle looks like. This is how a right angle triangle looks like. This angle here is what makes us call this triangle a right angle triangle, because this angle is 90 degrees. So we can as well draw it to face this way, so that I don't think it's because it's facing right or facing left. As long as we have one of the angle of a triangle to be 90 degrees, we call that triangle a right angle triangle. So this 90 angle is 90 degrees. This angle is also what? 90 degrees. So these are called right angle triangle. What did I say right angle triangle is again? A right angle triangle is a triangle that has one of its angle to be 90 degrees. And that angle is usually called a right angle. So that's why we call this a right angle triangle. Now, over to the next thing we want to learn. You should be able to identify the three basic sides of a right angle triangle. You know that every triangle has three sides, right? So for a right angle triangle, these three sides are named. They have names, right? You should be able to tell us the names of these three sides. And the name of the first side is usually the longest side that we consider, which is called the hypotenuse. It's called the what? The hypotenuse. The hypotenuse side. The hypotenuse. Now, the hypotenuse is the longest side of a right angle triangle. Now, but in some right angle triangle, you may not be able to quickly, at a glance, identify the longest side of that triangle. So, we usually identify that side by looking at the side that is directly opposite the angle 90 degrees. Now, what side is directly opposite the angle 90 degrees? You see, that is this particular side that is directly opposite the angle 90 degrees. So this side, we call it the hypotenuse side. In the case of this second right angle triangle, let's look at the side that is directly opposite. Yes, this side. So we call it the hypotenuse. It is the longest side of a right angle triangle, and it is always opposite the angle 90 degrees. That is how we get to identify the hypotenuse side. Now the second side, which is called the opposite side. The opposite side varies, right? It varies. Let me write it down. The second side of a right angle triangle is called the opposite. The opposite side. The opposite side varies depending on the angle that is under consideration, the angle we are considering. Remember, a triangle has what? Three angles. A right angle triangle has three angles, right? So the angle we are considering apart from this angle 90 degrees, let's assume we're considering the angle that is up here, and we label it as theta, the angle theta. The opposite side of this right angle triangle becomes this side. Why? Because it is directly opposite the angle that is under consideration. So how do we identify the opposite side of a right angle triangle? The opposite side of a right angle triangle is the side that is directly opposite the angle that is under consideration. So this is it. This side. So this side becomes the opposite. But let's assume we're considering this third angle and we label it as alpha. Now, the opposite side of this right angle triangle automatically changes if we're considering this side. That is why I said earlier that the opposite side varies. It changes. It automatically becomes this side because this side, when you look at it, is opposite. This side is opposite this particular angle. But for now, let's see we're considering the angle theta. So this becomes the opposite. And automatically the third side becomes the adjacent side. The third side becomes the adjacent side, right? So if this is a hypotenuse, this is the opposite, automatically this becomes the adjacent. If this is a hypotenuse and this is the opposite, automatically this becomes the adjacent. So one thing you will observe is that the hypotenuse is usually constant. It doesn't change. But the opposite and the adjacent side changes depending on the angle that is under consideration, the angle we are considering. So these are the three basic sides. These are the three sides of a right angle triangle. And quickly, over to the next thing we are doing today, the SOHCAHTOA. I believe you have seen this before and you have learned it before, the SOHCAHTOA. So today I want to quickly show you the three basic ratios of a right angle triangle. The three basic Trig ratios. Now, the SOHCAHTOA tells us it's the mnemonics that is telling us that the sine of the opposite side all over the hypotenuse, the side of the angle theta under consideration is equal to the opposite side divided by the hypotenuse. This is what it means. For so, we have the sine, like I said earlier, I said we are considering the angle theta. The sine of the angle theta degrees is equal to the opposite side all over the hypotenuse side. So means sine of the angle under consideration equaling the opposite side all over the hypotenuse. Same thing goes for this. I believe you're already beginning to see how it unfolds. The cos of the angle under consideration equals the adjacent side all over what? The hypotenuse side. And the third one, the tan of the angle under consideration equals the opposite side all over the hypotenuse, all over the adjacent side. So let's write it now. We have cos of theta to be equal to adjacent, all over hypotenuse. And tan theta degrees, always put your degree, equals opposite all over adjacent. Now, these are the three basic trig ratios we have when we are solving or dealing with right angle triangle. The sine of the angle under consideration is what? Opposite over hypotenuse. The cos or the cosine of the angle under consideration is equal to the adjacent all over the hypotenuse side. And the tan of the angle under consideration is equal to the opposite side all over the adjacent side. Now let's review what we have learned in today's class as I try to round up. We learned that in solving trig ratios, first of all, we must have a right angle triangle. You must have a right angle triangle. Trig ratios, you can only use it, this particular trig ratios can only be used for right angle triangle. That's the first thing we learned. And we'll also define a right angle triangle to be a triangle that has one of its angle to be 90 degrees. One of its angle to be 90 degrees, and that angle we call it the right angle. Now we also stated that a right angle triangle has three sides, and these sides are the hypotenuse, which is the longest side, or the side that is directly opposite the angle 90 degrees. And we have the opposite side, which changes depending on the angle we are considering. It is the angle that is the side that is opposite the angle under consideration, and the last side, which being the adjacent side, right? Having picked out the hypotenuse and opposite side, the third side usually automatically becomes the adjacent side. We now went further to talk about the SOHCAHTOA, where we talked about the three basic trig ratios being sine of the opposite side, sine of the angle under consideration is equal to the opposite side over the hypotenuse side, and cos of the angle under consideration is equal to the adjacent side over the hypotenuse, and tan of the angle under consideration equals the opposite over the adjacent. So don't forget SOHCAHTOA. In our next lesson, we are going to see how we can begin to solve questions using the SOHCAHTOA and how to apply the SOHCAHTOA in solving triangles. Right? I'll drop the note of this particular lesson so that you can go through it, and I will also drop questions there so that you can answer just a few questions. And if you have any questions for today's lesson, put it down and send it to my private chat, and I'll get to answer your questions. Thank you very much.